Hello everybody, I hope you all are doing fine, staying home, staying safe. Okay, so today we will learn about lines and angles. And before I start, I want to tell you one very important thing in real quick time, that every term that I mention, every term that you face while studying the subject, you must be aware of that, right? I mean, it's okay if you do not know in the beginning, but once you get to learn about that term, that concept, make sure you remember it, the next time you face the same topic, right? I mean, that's what makes your foundation, better and stronger. So keeping that in mind, I'm going to explain some basic terms that will help you understand this chapter, lines and angles. And those basic terms are, line, line segment, ray, angle. Okay, so let me explain. When we talk about line, then in terms of endpoints, a line has no endpoint. A line has no endpoint. In other words, we can say that a line can be extended in both directions forever. Okay, and this arrow represents that it can be extended forever. It goes forever. It goes on forever. In this direction and in this direction as well. So a line has no endpoints. This is the exact representation. The other term is line segment. What is a line segment? In terms of endpoints, a line segment has two endpoints, and we represent the endpoints with bold dots. So this is a representation for a line segment. Okay, a line has no endpoint and a line segment has two endpoints. Now the next term is ray. What is a ray? A ray has one end point. So as we learned earlier, we will represent end point with bold dots like here. So it has one end point, but from the other end, like line, it can go forever. Okay, we can also represent a ray in this way. This is the end point and this end goes forever. Okay, so a line has no end point and it can be extended in both directions like forever, and a line segment has two endpoints. We cannot extend it any further, so it has a finite length. A ray has one endpoint and the other end can be extended forever. We can represent a ray like this or this, both are same. Okay, now what is an angle, or when is an angle formed? Okay, what is an angle? See, this is one ray, this is another ray. When two rays meet or originate from the same point, when two rays, like this is ray 1 and the another ray which originates from the same point, then the space between these two rays is known as the measure of this angle. This is an angle. Okay, what did I say? When two rays originate from the same point, then the space between them is known as angle. And now, if I do not actually want to draw them, how would I represent them using alphabets? Okay, so a line can be represented as, suppose this end is A and this end is B. And this is ray OA, another one is ray OB. So how will we represent this? I'm considering just one case of ray. So this is represented as line AB. Okay, it can be extended in both directions. This is line segment AB. We do not necessarily need to mention the endpoints, that is enough. And this is the representation of ray AB. And for angle, we make a symbol like this and then we write its name. And now the name of this angle can be written in three ways. One, you can write it as angle AOB. This symbol is read as angle. So AOB, angle AOB. Or you can also write it as angle BOA, angle BOA. So if you are using three letters to represent an angle, so you write it either AOB or BOA, but in both the case, make sure that the vertex is always the middle letter. This is known as the vertex. The starting point of both the rays, is known as vertex. So when you're writing the name of an angle using 3 letters, make sure the vertex is always the middle letter. So you can write it as angle AOB or angle BOA. There is another way of writing or of representing this angle using just 1 letter, and that should be the vertex, angle O. All these 3 are same, this angle. Okay, I hope this is clear. Next, now as we learned just before a while that this is an angle AOB. Now if we try to measure this could be anything. The measure of this angle could be anything like 30 degree, 40 degree, 50 degree, anything. So, and the value of an angle varies from 0 degree to 360 degree, right? The value of an angle, the measure of an angle varies from 0 degree to 360 degree. Like, so based on these, based on this, we have different kinds of angles. Like what would we call an angle of 200 degree, or an angle of just 40 degree, an angle of, like 95 degree and all. So based on this, we have different kinds of angles. So next topic is types of angles. Okay, so the first type of angle is acute angle. What is an acute angle? It's very simple. An angle whose measure or whose value is more than 0 degree but less than 90 degree. More than 0 degree but less than 90 degree, right? Let's just say this again. I'm taking this example and I'm representing this angle as, let's just say, x. So this, the value of this x, if the value of this x is greater than 0 degree but less than 90 degree, then this angle is an acute angle. Here this angle x is what? Acute angle, right? Is that clear? I hope it is. Next, the other kind of angle is right angle. Okay, acute, greater than 0, less than 90 degree. Okay, that is not visible. Let me write it here. Greater than 0 and less than 90. This was your acute. So, next angle is right angle. It is very simple. A right angle is an angle whose measure is exactly 90 degree, right? And we know that when two rays are perpendicular to each other, the angle formed is 90 degree. So this is a representation of a right angle. So angle BOA or AOB or simply angle O is 90 degree, right? And if I represent this as x, I would say x is equal to 90 degree, and therefore x is a right angle, right? So when x is equal to exactly 90 degree, we call it right angle. Next, what's next? Obtuse angle. What is obtuse angle? An angle which is greater than 90 degree but less than 180 degree. An angle which is greater than 90 degree but less than 180 degree is known as an obtuse angle. So how can you represent this? Let's just say angle OAB. So this, okay, if you see if I draw this with a dotted line, let's just say this is x, you can see AOX forms a right angle, and now AOB is obviously more than 90, so it could be anything more than 90, be it 91, 92, 95, 100, 150, but less than 180, right? So if I represent this angle, let's just say with x, then what is the condition for an angle to be obtuse angle? That angle should be greater than 90 degree but less than 180 degree, right? If this is the case, then that angle, in this case x, is your obtuse angle, right? So when x is greater than 90 degree and less than 180 degree, this is obtuse angle. Okay, it goes in order, right? It goes in increasing order, ascending order, like from 0 and up to 360. More than 0 but less than 90. Next case, exactly 90. Next case, more than 90 but less than 180. So another one is obvious. What could be the next? The fourth one, the next type of angle is exactly 180. What do you say? A straight angle, opposite angle. Okay, so next angle is a straight angle. So what is a straight angle? An angle of exactly 180 degree is known as what? A straight angle. Like this. This is ray OA and another ray which originates from the same point O. Let's just say this is OB. So this is exactly 180 degree opposite. When two rays are opposite to each other, or when they are anti-parallel, so they are known as, you know, either linear pair or a straight angle. So this is 180 degree. If I represent this angle, let's just say with x, so here x is exactly equal to 180 degree, or we say x is equal to what? A straight angle. A straight angle. Okay, so when x is equal to exactly 180 degree, this is a straight angle. Next, the next type of angle is reflex angle. What is reflex angle? It goes in order, right? An angle which is more than 180 degree but less than 360 degree is known as a reflex angle. So how will we represent this? If we consider the previous case, this is these two rays, like ray OA and OB, or angle AOB or BOA or angle O. You know, these are straight anti-parallel, so this is making an angle of 180 degree, but we need more than 180 but less than 360. So what will we do? We will extend this by some more factor. Okay, so let's just say this one, anything more than 180 but less than 360, right? Make sure this is your 180. You do not complete the angle. If we complete, it becomes 360, so less than that would be okay, anything. So now this angle is what? If I represent this with x, then x, if we measure this would be greater than 180 degree. It is very obvious because up to here it is 180, so obviously this is more than 180, but how much it is? Whatever it is, but less than 360 degree, right? So this is a reflex angle. So if x is more than 180 degree but less than 360 degree, this is what? A reflex angle. There could be some other possible figures, like I would bend, you know, slightly more than 180. This is a reflex angle. This also reflex angle. You know, this also reflex angle. If I say this is also a reflex angle. Okay, now don't be confused. This looks like an acute angle. Let me tell you something important. this could actually be the representation for both. I mean, it is actually the representation for both. This is an acute angle and this is a reflex angle. So how do you differentiate? Remember, the angle subtended in the anti-clockwise direction is always taken as positive. The angle subtended in anti-clockwise direction is always taken as positive. Here, this is ray OB, this is ray OA. I am representing like this in anti-clockwise direction. So if I measure this, this is obviously like 20, 25, less than 90, but obviously more than 0. So this is an acute angle. Now how do I differentiate that this is not an acute angle? Here, the first ray is OA and the other ray, you're measuring like this. The other ray is here, right? So going in anti-clockwise direction, this is more than 180 but less than 360. If you will complete the angle, like starting from here and coming exactly there, this is complete angle. That would be another case, complete angle, when the measure of the angle is exactly 360. So don't be confused in between these two, that this is an acute angle and this is a reflex angle. Now you're not going to measure from here because this is the first ray is this one and the other ray is this. This is the first ray and this is the second ray. So we're going from first to the second. We're going from first to the second, right? So this is an acute angle and this is a reflex angle, right? So another kind of angle, last, what is that? Complete angle. What is complete angle? Obvious, okay? When x is exactly equal to 360 degree. So revise this. When x is greater than 0 degree but less than 90 degree, acute angle. When x is exactly equal to 90 degree, this is a right angle. When x is greater than 90 degree but less than 180 degree, this is an obtuse angle. And when x is exactly equal to 180 degree, where x is an angle, the measure of any angle, then this angle is a straight angle. And when the measure of any angle is greater than 180 degree but less than 360 degree, this is a reflex angle. And when the measure of any angle is exactly equal to 360 degree, this is known as complete angle, okay? And there is another one, an angle of 0. I will discuss it once I will talk about parallel lines. Now this is not the end. There are some more types of angles. This was based on measures of angle, and now the other ones, complementary and supplementary angle. Complementary and supplementary angles. So what are complementary and supplementary angles? It's very easy. When the sum of the measures of two angles, okay, when the sum of the measures of two angles is 90 degree, then those two angles are known as complement to each other. Let me explain this. I said this is an angle of what? 90 degree. It's very obvious. Like, let's just name it as this. So angle AOB is exactly 90 degree. Now if I divide it in two parts, in any two parts, I'm not saying equal two parts, in two parts simply, like this, and name this as angle C, and if I name this angle 1 and angle 2, okay? So here angle 1 plus angle 2, obviously this plus this is total, which is 90. So angle 1 plus angle 2 is 90 degree. So if the sum of the measures of these two angles is exactly equal to 90 degree, then these two angles are known as either complementary angles, or one angle is known as the complement of the other. Is that clear? When the sum of the measures of two angles is exactly equal to 90 degree, then the two angles are called complementary angles, or we can say angle 1 is complement of angle 2, or angle 2 is complement of angle 1. Now let's just say I divide this whole 90 degree into three parts, angle 1, 2, 3. Now angle 1 plus angle 2 plus angle 3 is still 90 degree, right? Like this part plus this part plus this part is equal to total. But we cannot say complement that these three angles are complementary angle. For an angle to be complementary, for angles to be complementary, we can take only two. So the condition is when the sum of the measures of two angles, is exactly 90 degree, then the two angles are known as complementary angles. And the supplementary is very similar to complementary, only the number changes. So we have just learned that this is, straight angle and its measure is 180 degree. Now let's just say I divide randomly into two parts and I name this as angle small a and a small b. So here it is very obvious that small angle A and angle small b, okay, this part plus this part is equal to total, which is 180 degree. So what is supplementary angle? When the sum of the measures of two angles is exactly equal to 180 degree, then these two angles are either called supplementary angles, or one angle is known as the supplement of the other. I can say A and B, angle A and angle B are supplementary angles, or I can say angle A is the supplement of angle B, or angle B is the supplement of angle A. For example, if I take an example of complementary angle, so the question would be very simple, like the question would be like, find the complement of 26 degree. The question is, find the complement of 26 degree. So since the sum of the measures of two complementary angle is 90 degree, therefore the complement of 26 degree would be 90 minus 26. If one of the angle is 26 degree and the question is find the complement of 26 degree, then the answer would be the complement of 26 degree is 90 minus 26. And why did I write this line? Because the sum of the measures of two complementary angles is 90 degree, right? So 90 minus 26 is your answer. This is 64 degree. The same question could be find the supplement of 26 degree. So you will write the same. The supplement of 26 degree is equal to, what is it? 180 degree minus 26 degree, right? If the question is find the supplement of 26 degree, the answer would be the supplement of 26 degree is equal to 180 degree minus 26 degree, right? Actually, this is, in this class I'm discussing all the concepts. We will do plenty of questions in the next video. For now, I'm just discussing every single concept that is in this chapter, right? This is very simple. We will do some good question as well in the next class. So after, some basic terms and then types of angles and then complementary and supplementary angles, we have some more concepts like, let's just say, the next one is adjacent angle. Adjacent angles. Now, what are adjacent angles? Two angles are said to be adjacent if two angles are said to be adjacent angles, or two angles are said to be adjacent to each other when there are three important conditions. Listen carefully. The first one says if they have a common arm, or you can say ray. If they have a common arm. The next condition is if they have a common vertex. And the third condition, which is a little bit complex but not difficult, it says the non-common arm must lie on the opposite sides of the common arm. Okay, understand these three. I will explain this. I said two angles are said to be adjacent angles if they have, first condition, if both the angles have a common arm. Second condition, if both the angles have a common vertex. And the third condition is the non-common arm must lie on the opposite sides of the common arm, right? On the opposite side of the common arm. Let me explain this by an example. Okay. Okay, this is the question. In this figure we have two angles, angle AOB and angle BOC, and we have to check whether these two angles are adjacent to each other or not. What is the question? We have to check whether angle AOB and angle BOC are adjacent to each other or not. Okay, so how will we solve this question? Understand this very carefully. It's simple up to the second term. I guess the whole concept is simple, and however, since this is the very first time, so pay attention. If I split angle AOB into the rays it is formed by, so we see angle AOB is formed by two rays. Just focus on angle AOB. Angle AOB is formed by two rays, ray OA and ray OB, right? Angle AOB is formed by ray OA and ray OB. And if I talk about another angle, angle BOC, then angle BOC is formed by two rays OB and OC, right? Angle BOC is formed by two rays OC and OB. Now, if we see it has two arms or two rays, it has also two arms or two rays, and if we see carefully, OB is present in both angles. Ray OB is present in both angles. So our first condition, that two angles are said to be adjacent if they have a common arm. The first condition is satisfied here. In both the angles we have a common arm OB, right? Next condition, it says it must have a common vertex. It must have a common vertex. See, angle AOB and angle BOC. And as we learned earlier, that vertex is the middle letter, right? So here, angle AOB, the middle letter is O. Angle BOC, the middle letter is, again O. Meaning the vertex is common. So the second condition is also satisfied. Third condition, the non-common arm. Obviously the arm that is not common. If OB is common, then very simple, OA and OC are not common. Meaning they are non-common. So the non-common arms must lie on the opposite side of the common arm. If this is the common arm, right, OB, according to this question, OB is the common arm, then the non-common arms OA and OC are on the opposite sides, okay, on the opposite side of this common arm. Is that clear? It has a common arm, common vertex. Third condition, the non-common arms. First of all, you need to identify, what are the non-common arms. If OB is common, then OA and OC are non-common. So where these two rays should be, the non-common arms must lie on the opposite side, on the other side, okay, of the common arm. So in this question, OB is the common, so OA and OC, which are non-common arms, they must lie on the opposite sides. Or in other words, the common arm must lie in between the non-common arms, right? So the third condition is also satisfied, and therefore we can say angle AOB and angle BOC are adjacent angles. I hope that is clear, and if not, you can ask your doubt in the comment section. The next question, the next concept is linear pair of angles, but you will you will be able to understand linear pair of angles if you really understood adjacent angles. I will draw the same figure again. The next concept is linear pair of angles. So what are linear pair of angles? Okay, it is 95% similar as adjacent angles. So if I draw the same figure that I draw earlier, like okay, we proved that these two, actually we checked that these two are adjacent angles. Now when what is the condition when two adjacent angles will be known as linear pair of angles, right? What is the condition that will make two adjacent angles as linear pair of angles? So listen, this is very simple. We know that OB is the common arm in angle AOB and angle BOC. OB is the common arm and the non-common arms are OA and OC, which is obviously lying up on the other side of the common arm OB. So these two are adjacent. The same two angles AOB and BOC will be known as linear pair of angle if you make a little change here. If I extend this non-common arm OA up to a point where it becomes opposite to the another non-common arm OC. Let's just say I drag it over here. Let's just say this is my OA. Okay, these angles AOB and BOC are still adjacent, but at the same time these two angles are linear pair of angles. So what is the definition? Two adjacent angles are said to be linear pair of angles. Two adjacent angles are said to be linear pair of angles when the non-common arms are opposite to each other, right? Two adjacent angles are said to be linear pair of angles when the non-common arms, which is obviously OA and OC, when the non-common arms are opposite to each other, anti-parallel, right? Now these two are linear pair of angles. Is that clear? I will explain it. I don't know, but I will explain it